Topic 1, test review. First thing is we're talking about graphical features. Okay, so on number 1, it says identify the following using the graph up above. What does domain stand for? What are we looking at? X values. Okay, reminder, X goes left to right. So we're looking for our smallest X to our biggest X. Now remember, we're basing it off of the graph that we have. Okay, we're not basing it off of the X-axis. Okay, so we're basing it off of the specific graph. So what is my smallest X value? It is 0. Yep, because we start here. Good. What's my highest X value?
14. Oh, 14.
Careful. We want X values. So it would be 8. Yep, so our domain is 0 to 8. Okay, what's range?
It's the Y values.
Y values, where we go up and down, right? What's my smallest Y value?
0.
It is 0. Good. What's my highest Y value? I know some of you put 12.5. It is 13. Okay, but our highest Y value is 13. What does it mean to be an x-intercept? Touch across the x-axis. Where does that happen? 0, 0. Yep, make sure you write them as coordinates. Good. What about y-intercepts?
Where you cross the y-axis.
Yep, do we cross or touch the y-axis? 0, 0 again. Yep, so 0, 0 is an x and a y-intercept. Okay. Increasing and decreasing. Remember we read these all together. How do we read them? Left to right. Okay, so starting at our leftmost point, what are we doing first? Increasing. Where do we start increasing? 0 all the way to about right here.
Yeah, because we stopped.
We kind of stop increasing, right? What's that value? 5. So 0, 5. Usually when we stop increasing, we start doing what?
Decreasing.
But what do you notice from here to here?
It goes back up.
It's just constant, right? So nothing's happening there, so we just stay. But what starts happening here again? Increasing. Where do we start increasing again? 6 to 8. Yep. Remember with increasing and decreasing, what values do we want? We want x values. Yep, remember you read left to right. So we want x values. Did we have any decreasing? No, so there's just none. All right, number 2 says find x and y intercepts of the following function. Up above, we found x and y intercepts by just looking at the graph. Okay, what do we have to do if we don't have a graph? You could make one, but if we have to do it algebraically, what do we do? What did I have you make? Remember I had you make a t-chart between your x-intercepts and your y-intercepts. Yep, go ahead and make your t-chart. What do we know about x-intercepts? What's always going to be true? Yeah, y equals 0. Okay, but I don't see a y here. F of x is y, right? So we can rewrite this as y equals x squared minus 25. So if I know y equals 0, what do I do with that? Plug it in for y. So this is going to turn into 0 equals x squared minus 25. What is our goal from here? What do we want to do? We want to get x by itself. What should I do first? Add 25. So I get 25 equals x squared.
Square root.
Yeah, the opposite of a square is a square root. So what is the square root of 25? 5. How many answers should I have here?
2.
Because
It's a square root.
yeah, yeah, we're taking the square root, right? And if we ever see this squared, we know we're going to have 2 x-intercepts. Okay, so our answers are x equals 5 and x equals negative 5. Good. Okay, what's always going to be true for y-intercepts? This time x is always going to equal 0. So if I know x equals 0, what do?
Plug it in.
Plug it in for x. So this turns into y equals 0 squared minus 25. What is 0 squared? 0. What's 0 minus 25? So y equals negative 25. Okay. So what did you write this?
Yeah.
So that's not an intercept, that's a different coordinate. So you can write these as intercepts if you want to, or you can just leave them as what we have them here. If you wrote these as an intercept, though, it would be like 5, 0 and negative 5, 0. and this one over here would be 0, negative 25. Okay? Does that answer your question? Okay. All right. Number 3, it says identify the translation of the parent function f of x equals x squared, and then they give us a new function. What does the word translation mean?
Like,
If I tell you to translate something,
like the slope, like the line.
it's like to move, right? So some of you said slope, which is correct because we're moving it, right? However much. So translation means how much it's moving from the original. How many things are happening in our new function here? There's 2 different things happening, right? What's this plus 3 do?
It flips it left.
Right, is this with the x value or the y value? X value. Do we think normal or opposite?
Opposite.
Opposite. So we have to go left 3. What about this plus 2? Is that talking about the x or the y?
The y.
That's talking about the y. Do we think normal or opposite? Normal. So that would tell us up 2. So then pick which one. And I do agree it is A. Okay. What if I put a negative sign in front of here? What else would that do? It would flip it upside down, right? What does this graph look like, this parent function?
It's U.
That one is the u, right? So if we flipped it upside down, it would look like this. Okay. Number 4, starting to deal with piecewise functions. Remember, piecewise functions just means we're dealing with more than one function at a time. Okay, so in this piecewise function, how many total functions are there? 3. Okay, remember it's just how many rows there are in the piecewise. 1, 2, and 3. Okay, number 5. I am going to word a lot better so that you know what I'm talking about on the test. Okay, so I'll ask specifically what I want on this one, but this is what I expect. It says, what can you tell me about the value of x equals 2? Okay, so remember when it gives you an x value, you want to look through the intervals. Okay, so looking at this one first, does x equals 2 fall into that interval? No, 2 is not between 0 and 1. Does it fall into this interval? Is it in between 1 and 2? Yes. Okay, so we know that x equals 2 is in function 2. Okay, what do we know about x equals 2 in function 2? Specifically with the sign here. It's equal to, okay, so we know x equals 2 is equal to in function 2. What does that tell us if I graphed it? What would we need if I graphed it? If it's equal to, we need closed circle. Yep, so this question is just asking you how you would graph it. Okay, now we also want to check function 3. Is 2 in function 3? It is, right? Because we still have this 2 here. So we know it's in function 3. Okay, what do we know about function 3 though? Is it equal to like it was in function 2? No. So this one is not equal to, because it doesn't have that equal sign underneath. Since it's not equal to, how do we graph that? We have to have an open circle. Okay, like I said, I will reword that so there's no confusion there. Okay. Number 6. It tells us what are the following values. So it gives us 3 x values, and we want to figure out what their y value would be if we plugged it in. Okay, so x equals 1. You're asking yourself which interval that falls in. So looking up above, is 1 between 0 and 1? It is, right? So we have 1 here. Is it equal to there? No. So does it fall in function 1? No. What about function 2? Yes, because we have the equal to sign with the 1. So we're activating this equation here. So we know it's in function 2, so I activated 3 minus x. What do I do with my x value? Plug it in. So we get 3 minus 1, which is 2. So our answer is 2. Same thing for x equals 3 and x equals 8. Which function does 3 fall into? Let's start from top to bottom, because that's how I would want you to go through it. Is 3 between 0 and 1? No. Is 3 between 1 and 2? No. Is 3 between 2 and 4? Yes. So we're activating this function here. Is there anywhere that I can plug in an x into this? Is there any x that I can plug in? No. So what's my answer? Not none. It's 1. Remember, if there's a constant and there's nothing to plug in, that's just your answer. Okay, if there's a constant there, that's your answer. What about x equals 8?
No,
Why?
because there's no 8 and I think there's 3.
Right, some of us are like, oh, I'm just going to pick the biggest interval, but it's 8 in between 2 and 4. No, so if it doesn't fall into any of these intervals, your answer is just none. Okay. Moving on to number 7 and 8. Biggest thing here is we got to read the directions. Okay, so here it says use the sequence to answer questions 7 through 9. So 7, 8, and 9 using this sequence here. Okay. On number 7, it wants us to write the explicit definition. What a lot of you did yesterday is you wrote +3, and that was your answer. Okay. You have a good key part there, but that's not the explicit definition. Okay, so I want everyone to write this definition down. Our explicit definition is AN equals A1 plus D times N minus 1. Okay. There's 2 things we need to write the explicit definition. Okay, we need A1 and we need D. What does A1 stand for?
First coordinate.
First term, right? What's the first term of the sequence? 9. What does D stand for? The difference or the distance or the pattern that's happening. What's happening in between every single one?
Going up 3.
We're going up 3. So we know our difference is positive 3. Okay, once I have that, now I can write my equation. So what this turns into, AN equals, what's A1? 9 plus 3 times N minus 1. This is what I want for number 7. Okay, so the number 8, it wants to know what the 50th term is.
Plug 15 for N.
Right, we're going to use our explicit definition here. Could you add 3 50 times?
Good.
You could, but is it much easier to do it the other way?
Yes.
Yes. Okay, so what we're doing is I'm finding A50. I'm going to plug 50 in for N. Okay, so this turns into 9 plus 3 times 50 minus 1. What do I need to do first here? Parentheses. Yep, so this turns into 9 plus 3 times 49. Here's something that I see a lot. Okay, everyone pay attention. I see a lot of us doing this, and we're getting the wrong answer. Does anyone know why we get the wrong answer?
Guess what's multiplication for?
Yeah, order of operations says we have to do multiplication first. Okay, so let me erase here. Therefore, we have to take 3 times 49 first. So what is 3 times 49?
147.
Thank you. And then lastly, we just add together. What's 9 plus 147? 156. So that would be our 50th term of the sequence. Number 9 says, what is the sum of the sequence? What sequence are we using?
The last one.
The one that was on the front page, right? So our sequence there, if you want to rewrite it, was 9, 12, 15, 18, and 21. Now, what does sum mean?
All.
Like the answer to an addition problem, right? If I added everything together. Now, could you easily add these together? Yes, is that what I want you to do? No, I want you to use the formula. Okay, so remember the formula for a sum is n times a1 plus an divided by, nope, sorry, not n, 2. How many things do we need in order to use this? We need 3, right? We need to know what n is, we need to know what a1 is, and we need to know what an is. What does n stand for? Number of terms in the sequence. How many terms are in our sequence? 5. A1 is first term, which is 9. Thank you. What does an stand for? If I tell you to find an, what does that stand for?
The last.
It is the last term. Yep. An stands for our last term. What is my last term in the sequence? 21. Now that I have all 3, I'm just going to plug it in. Okay, so we have S of n equals 5 times 9 plus 21 divided by 2. Order of operations, what has to happen first? Yep, add together, so we get 30. Divided by 2, what comes next? Multiply 5 and 30, so we get 150 divided by 2, final answer? 75. How can you check your answer? Yeah, to check your answer, you can go ahead and add them all together to make sure you got it correct. Okay, but I do want to see you using this formula here. Okay, because that formula is going to come in handy in number 10. Okay, so number 10, it wants a similar thing. It wants you to find the sum of the sequence. However, we have it in a different notation this time. What is this notation called?
Sigma.
Sigma. Told you never forget it. Okay, sigma notation. So we're still using our same sum formula since we're finding the sum. Okay, and we still want to look for the same three pieces, n, a1, and an. This time, does it give you those directly?
No.
No, unfortunately not. How do we know how many terms are in the sequence in sigma notation? It is the top number. Yep, this number right here tells you what the total is. So our n value is 7. How do I figure out what my first term is?
Plug in 1 for n.
Where'd you get the 1 from?
Bottom.
Yep, plug in our bottom number into the equation here to find a1. So this turns into
1.
3. What'd you say?
Oh, never mind.
So this turned into 3 times 1 minus 2. What's 3 times 1? 3 minus 2? 1. So we get 1 for a1. How do I find what an is? Right, we have 7 terms, so to find my last term, I'm going to plug 7 into that equation. So this turns into 3 times 7 minus 2. What's 3 times 7? 21. Minus 2 is 19. Do we have everything? Yes, so we plug it into our formula. We have 7 times 1 plus 19 divided by 2. What happens first? Yep, so we get 7 times 20 divided by 2. What's 7 times 20? 140 divided by 2 is 70. Number 11, it says use the graph to solve for the solutions. I'm going to reword this. I want you to write it how we normally have. So we usually write solutions as coordinates, right?
Yeah.
So it gives you the graph. Do you really have to do any work? No. How do we know what solutions are?
It's the points I can meet up
It's the points where they intersect, right? How many do we have? There is 2. So 1 here and 1 here. Is that good enough?
No.
No, what do we have to do?
Coordinate pairs.
Write them as ordered pairs. What is this one going to be written as? It is negative 1, 1. If you wrote it as 1, negative 1, is that the same thing?
No.
No, that would put you over here, right? Is that a solution? No. Okay, so make sure you have them in the order of x, y always. What about this guy here? It is 3, 3. So those are my 2 solutions. Okay. Number 12. I give you 2 graphs, and you are going to solve the equations finding their intersections. Okay, so on these ones, you actually have to graph them. Okay, so let's go over how to graph and the process we take for this. What do I want you to do first with this? Separate them as their own. So we get y equals, our first equation is 3/4 x plus 1. Our second equation is y equals absolute value of x plus 2 minus 3. Which of those are you most comfortable with graphing? Top one, right? That's slope-intercept form. What is that graph going to look like? Yeah, our slope is positive, so we know our line is going to be in the upwards direction. Where do we get our starting point from? The 1, right? That's our b value, which is 1. Is that on the x-axis or on the y-axis? Y-axis. Where do I get all of my other points from? Slope, which is 3/4. So we're going to go plot that here. Start at 1 on the y-axis, and then go up 3/4. How far do you graph? Till you can't. Yep, go in both directions there. So here's my slope intercept form line. That one's done. Now I need to graph our second function there. What's that graph going to look like? How do you know? Yeah, when you have the absolute value bars, this is going to look like a V. Where do we get our starting point from for the V? And both of these right here tell us where it's at. Because remember, our parent function started at the origin, but it's being translated here. So what does that plus 2 tell us? Yeah, there we go. We're going to go left 2 and then down 3. So that's going to give me my starting point. I'm going to go from the origin, left 2, down 3 for my starting point. For a v, how do I get all of the other points? Up 1 over 1, continuously. Yep, until you can't go anymore. Yep, just a stair step. What do you notice? It doesn't work out very nicely, okay? When it doesn't work out nicely, what do? Just circle it and move on. Yep, I'm not going to make you try and write that as a decimal or a fraction, okay? On the test, they do work out nicely. I double checked. Okay, so on the test, they will work out nicely. Any questions on number 12a? Okay, so remember, when you're given an absolute value function, you're getting the starting point from wherever it's being translated to. Okay. Number 12b. What do we need to do first? Yeah, we need to separate them. So we got y equals 1/2 x minus 2. And our second one is y equals x squared plus 4x plus 1. Again, which one of those are you most comfortable with graphing? Top one. What's that graph going to look like? Positive slope line. Good. What's my starting point? -2, and my slope is 1/2. So start at -2. I'm going to go up 1 over 2. Okay. What about that bottom line there, this one here?
ABC.
Yeah, you can think ABC, right? What's our graph going to look like?
It's gonna look like a U.
Yep, because the squared, whenever you see a squared, it's always going to look like a parabola or a U. Okay. Can we get our starting point just by looking at that? No, this is the x equals -b over 2a, or when you guys said ABC. So following along, we get x equals -b over 2a. What number is technically right here?
1,
A 1. So we get 1. That's our a. What's b?
4,
4. C is 1. So what do I plug in for -b?
4,
Yep, -4 over 2 times
1,
1. So we get -4 divided by 2, which is -2. Now keep in mind, what we're trying to find is our starting point of our parabola. So what we just found is the x value of our starting point. What else do we need to find in order to graph? The y value, okay? We have the x value. How do we find what the y value is?
You gotta plug it in.
How do you know?
I don't know.
How do you know?
It's X. You just plug in the X's.
Yeah, we're going to plug it in the x's. And notice, we know what y equals, right? We know y equals this whole equation here, so we're going to plug in -2 for the x's. So, following along, we get y equals, plugging in -2 to here and here, we get -2 squared plus 4 times -2 plus 1. From here, we just evaluate. What's -2 squared? Positive 4. What's 4 times -2? -8 plus 1. So then type this in your calculator left to right. What's 4 minus 8? -4 plus 1 is -3. So that just gave us our y value to our starting point. Okay, so then we just go plot that, starting at -2, -3. Even though it crosses right away, are we done?
No, you guys are gonna do that.
We still got to draw our graph, right? Yeah, how do we get all the other points? Step pattern.
1, 3, 5.
Good. Yep. The step pattern's always going to follow your odd numbers. Remember, those steps are how much you go up. Okay, how much do you go over every time? 1. So we're going to go over 1, up 1 for our first step. Over 1, up 3 for our second step. What would our third step be? Up 5. And we do end up falling off the graph. Okay, so then go ahead and draw your U. How many solutions do we have?
1.
Only have one. Did it work out nicely? Okay, since it worked out nicely, what do we have to do? Write it down. What is that coordinate?
-2, -3.
-2, -3. Good. Last one here. Solving systems of equations. This time we have it algebraically. Okay. Keep in mind on your test, I will have more than one on there. Okay, on the review, I just put one. But you have had plenty of practice with these from your worksheet. So, with solving systems of equations, what's the goal?
Make one of them cancel out.
You want to, what do you mean by one of them?
Like the x.
Yeah, you want to get either the x's or the y's to cancel out. So, looking at the x's, what number is technically in front of all of these? A 1. So, I'm going to put a 1 there just so we can visually see it. Can I directly cancel out our x's? No, not yet. Can I cancel out our y's? No. So when we can't cancel them out, we want to see if we can turn one equation to cancel one of them out. What are we thinking?
But why?
Yes, why?
Because they're both negative if we turn one of them positive.
Right. Notice how our y's already match up, but if I add them together, will they cancel out yet? No. What do I have to change about one of them? Yeah, we need to switch the signs. I'm just going to pick the bottom one. I'm going to multiply by a -1. Does it matter which one you change? No. Okay. So, what we have left is 2x minus y equals 7. I didn't change the top one, so I'm going to keep it. Okay. When you multiply by a -1, what happens?
Becomes positive.
Yeah, the signs change, right? So positives turns to negatives, negatives turns to positives. Do not forget about these also. Okay, also change those. So what's my next step here?
Add them all.
Yep, I'm going to add them together. 2x plus a -x is x. What happens to the y's?
They cancel.
Cancel. What's 7 plus a -10?
-3.
-3. Now, if you didn't get anything to cancel in this step, can you move on?
No.
No, you got to go back and see what you can change. Okay, I'm going to ask you this. Could you have changed the x's if you wanted to? Yes. Does it matter what you change?
No.
It doesn't. Okay, as long as you get something to cancel out and you do it correctly, you should still get the same answer no matter what way you went. Okay? Once I have the x value, is this my answer?
No.
No, what do we have to do? Yeah, why do you pick the top one? Right. Really, it doesn't matter which one you pick. I just usually pick the one we don't touch. Okay? So I'm going to rewrite. I'm going to pick that that top equation. Now I'm going to put, I didn't mean to put the 1 there. Now I'm going to plug in what we know. So 2 times what? -3, yep. Minus y equals 7. What's 2 times -3? -6 minus y equals 7. From here?
And then we add 6.
Add 6. So we get -y equals +13. But then what do we have to do next?
We have to divide -1.
Divide by -1,
-13.
which does give you -13.
So I did have it right, even though I didn't do I did it times -2 for the bottom one. And I stuck it in the same.
Oh, you can, yep, that's fine. Yep. So people watching the video, what they said is that they ended up changing the x values, correct? You ended up changing the x values?
Well, I just multiplied the bottom one by -2.
Because then you wanted to cancel out those, right?
Yeah.
Yes. Yep. So they said they multiplied this bottom equation by -2 to get their x's to cancel out. But did you guys end up getting the same answer?
Yeah.
Yes. So it should work out no matter what. How do I write the answer?
-3, -13.
-3, -13. Yep. So again, as long as you do it correctly, it doesn't matter what you change or how many things you change. Okay? All right. Are there any questions specifically? Okay. With the systems of equations, do you sometimes have to change both equations? Yes. Yes. Okay. So be aware of that.